First thing, what is chalk? Some of you will recognize the whip-snake lion. The rest of the photograph there is the chalk quarry at Kensworth on the top of Dunstable Downs. It's difficult to get the full scale of the quarry, but if I just point out, there is a lorry sitting about sort of halfway up the screen on the right-hand side where the pointer was then. The wheels on that lorry are probably at least 6 to 8 feet in diameter. So that gives you some idea of the scale that we're talking about. It's a huge hole. You can't get into it very easily nowadays, but it is still possible. So we're very quick to make use of this chalk, and we have to have a look at it to say what's inside a lump of chalk. Chalk is actually a biogenic rock. It's composed of the skeletal remains of a whole number of different animals and plants. So just to give you some idea, whizzing around this image, if I go from left to right, to the bottom left, we have bivalves such as Inoceremus, we have bryozoa and sponges, we have the echinoderms, famous ones being the micrastas and the echinocoris. We get microfossils like ostracods, we get brachiopods, we get sponges. This is Porosphera. And then we get the foraminifera. Those are the things that I work on. And then down on the bottom right here, we get the calcareous nanoplankton. And they are algae, single-celled algae. And we'll come back onto these as we go through because they are the key element of the chalk as a sediment. We also get bigger fossils like this occasionally, big Parapazosia ammonites. This one's down on the seafront at Brighton. Fortunately, nobody's going to move it. So hopefully next time anybody goes down onto the marina, you can have a wander along there and have a look. So we do get bigger fossils, and it's not all microfossils like the things I work on. And we end up with the classic, if you like, cliffs that you tend to assume is typical of the chalk, with these regular flint bands running through probably about every meter on average through the chalk. I'm the idiot standing close to the cliff edge there in the bright yellow jacket. Fortunately, there's an even bigger idiot to my left, standing even closer to the edge, and that's Dr. Liam Gallagher, who I've had the privilege of working with for the last 30 years now. And Liam is the nanoplankton expert to my forums. So we didn't fall off. We still both survived and went on to do greater things, I think. So let's move on. When that chalk was being deposited, it's quite a unique rock. So we have to ask ourselves, what was unusual about late Cretaceous time when that chalk was being formed? So if we have a look at the global situation, this is around about early Cenomanian times. I'm just putting a box up at the top there in red. That is Northern Europe. So you can see that the continental shelf of large parts of Northern Europe was underwater. It was totally submerged, and a whole series of factors come into it. So we've got a global greenhouse climate. Paleo temperatures, sea surface temperatures were way higher than they are today. To give you a real example, there is good evidence that at the end of the late Cretaceous in the Maastrichtian stage, temperatures were up in the mid 30 degrees centigrade. I mean, that is really pushing temperatures right up before they drop down during the late Maastrichtian. So we've got high global greenhouse climate impact. Because of that, there's no polar ice sheets. We're seeing major flooding of the continental shelves. And because the continental shelves are flooded, we're getting less runoff from the continents themselves, less erosion. So there's much fewer continental sediment sources pouring onto the shelf area. So we get these pure white chalks. Seawater is clear. It's not typically northern hemisphere muddy sea. This is really nice clear seas. So sunlight penetrates through, and the chemistry is slightly different, and it changes through time. And we are seeing a low magnesium calcium ratio in the seawater. Now, this is important because that sort of chemistry is an absolute dream as far as these nanoplankton or coccoliths are concerned. These are modern day coccoliths. They still occur in their billions in modern day oceans. And if they're occurring in their billions in modern day oceans when temperatures are so much cooler than the late Cretaceous, then you can imagine how much they bloomed in late Cretaceous oceans. The actual algae themselves are single-celled, and they exist inside a sphere of calcareous plates. They build these plates around themselves. There's various arguments on why the plates were put in place, whether it's for protection or possibly even refracting sunlight, because they are photosynthesizing plants in effect. So they need the sunlight to get in there. But when they die and the coccospheres break down, you end up with a mush on the sea floor of individual plates and fragments of the coccospheres. These are what we call coccoliths, and that is what goes to form the sediment, and that's what chalk is made of. So I put this one, I always put this image up as much to confuse people and say, well, do you recognize where it is? If you know it, it's quite a distinctive coastline. But what I'm focusing on is this cloud in the lower central area of the image, which is a cloud of calcareous nanoplankton. You can see it. This is a photograph taken from space. And this is just a mass, literally billions of those coccospheres living up in the surface. This is actually off the coast of northeastern Canada. So I guess it's not too far off the Gulf Stream. And obviously where you've got the warmer waters, these algae will bloom. And if I take you a bit closer to home, this is a well-known photograph, I guess. This again is an absolute mass of billions of coccospheres. And this is a bloom, obviously off the Devon Cornish coast. And it's a single species. It's a species called Emiliana huxleyi, and it's probably the most common organism on the planet. So they occur by the billion in modern day oceans, and in late Cretaceous oceans, they really did clog the oceans almost, if you like. This is what was dying and forming the sediment on the seafloor. So chalk is initially a coccolith and foram ooze. Here's a living foram. They die, you get the shell, or what we call the test of a foram breaking down. Similarly, there's a coccolithophorid. This is actually E. huxleyi. These things break down, we get individual plates, and those plates mush together. This is a North Sea chalk, and you can actually still see, you do get occasional coccospheres in there, as well as the tiny plates. So that's what's forming the chalk. So, having established how it was formed in the first place, what does it look like under London? I put this in just so that you get a general feel for it. It will start right over on the left here. Here's Dunstable on top of the Downs. So we've got the middle and lower chalk in the old terminology. And then on top of that, this light green is the upper chalk. So part of what is now called the white chalk. And you can see it dipping into the London Basin. There is some structure under London, but in fact, it comes up as a basin on the North Downs to the south of the capital. So we've got this basin that stretches across the southeast, and where Dunstable is over on this left-hand side, you can see it's labeled the Chiltern Hills, and that's where the examples I'm going to be giving you tonight come from. In terms of the time scale we're looking at, this is the chalky. This comes from the Geology of Hertfordshire book. I've put that red line across the top there because there is no chalk younger than 85 million years in the London Basin on a broad basis. Anything that is younger than the lower or early Santonian stage, you just don't see it. You do pick up some younger chalk on the flanks of the basin, but certainly from the Chiltern's point of view, the section of the chalk that we're going to be looking at is this section down here. Really running through from what is the Plenus Mars, so the boundary between what's now called the grey chalk, and then the lower part of the white chalk subgroup, which effectively encompasses the majority, virtually all of the old middle chalk, in old speak, if you like.